Alright, welcome back guys. We're going to look at this actually pretty short support section for section 3.6. And this is on basically translating a verbal algebraic expression to a mathematical algebraic expression, okay, using variables and numbers. So these are some examples of algebraic expressions. An expression, guys, does not have an equal sign. The minute that you see an equal sign in it, it is an equation. So these are all expressions. So 91 plus 76, 7 divided by 8, 5 squared minus 3 squared. And then, you know, these are algebraic expressions down here. They're called algebraic because they have variables. So x plus 76 is an example. D divided by t, or x squared minus y squared. These are all examples of algebraic expressions. And so you can see the definition. An algebraic expression consists of variables, numbers, and operators. Okay, so it could be addition, subtraction, division, multiplication. It could involve powers, okay, or even square roots or cube roots. And it says we usually use these expressions to represent some scenario that we're trying to model. Okay, so we're going to see this. And again, the difference between an expression and an equation is that an expression does not have an equal sign. Alright, so translating to algebraic expressions. So what's going to happen is we're going to be given an expression basically written in words. We're going to have to represent that expression using variables, numbers, and also operators. And so this is a chart with some key words that will help you figure out, you know, which operations to use. So if you see any terms or any phrases of this nature, they're going to denote addition. So add, sum, plus, total, increased by, or more than. And then for subtraction, any of these terms, subtract, difference, minus, decreased by, less than. And then for multiplication, multiply, product, times, twice, of. The word of means multiply. Usually it deals with percentages, though, when you multiply percent times some number. And then for division, we've got divide, quotient, divided by, ratio, and then per. So when you say miles per hour, that's actually the number of miles or the distance divided by the time in hours. Okay, so that's a rate. So let's try example 1 here. So it says 8 less than some number. So this is the expression. We want to write this using variables. It says use x as the variable to represent the unknown number. So anytime you see this, some number, that means we don't know what that number is. That's why we're going to use a variable. So remember, a variable is just a letter in most cases that represents some unknown number. So x represents some number, and then if we say 8 less than x, that means you take 8 away from x. So this is going to become x minus 8. And this is the expression. X minus 8 represents, used mathematically, 8 less than some number. Okay. Example 2, 22 more than some number. So again, we're going to use x to represent this unknown number, and then 22 more than. So more than is going to connote addition. So this one you could write x plus 22, or you could write 22 plus x. The order doesn't make a difference because we're adding. And order does not matter with addition, guys. However, order does matter with subtraction. So that's why this previous problem, 8 minus x would have been incorrect. Let me put this in the notes. Okay, so be careful. If it says 8 less than some number, that means we're taking 8 away from this unknown number. And we're not taking the unknown number away from 8. That's what this second case would represent. Okay, number 3. 5 more than twice a number. Well, 5 more than, that probably means we're going to be adding 5 to something. Again, we don't know what that number is, so we're going to use x. But this says 5 more than twice a number. So you've got to know what this word twice means. You can look back in your chart here. Twice means multiply. More specifically, it means multiply by 2. Okay, if you say, he makes twice as much money as I do, that means he makes double. Okay, or in other words, you take my salary and you double it, or in other words, you multiply it by 2. So, what I'm going to do, 5 more than twice a number, well, twice a number is going to be represented by 2 times x. Okay, 2 times whatever that unknown number is, and then 5 more than that just means you're going to add 5. Okay, so you've got a product, the 2x, or 2 times x, plus 5. Now again, since we're just adding 5, the order doesn't make a difference, so you could also have written this expression 2x plus 5. These would both be acceptable. All right, now with number 4, what we're going to do, let's see. Well, we're going to do the same thing, basically. It says Joe had $D before spending $19.95 on a movie. So in this case, we're not going to be using x, we're going to be using this variable D. Lots of times, guys, when you're working with a real problem, you'll use a variable that'll represent whatever it is that you're trying to find. So like in this case, dollars, so we're using D instead of x. And so the question is, how much did Joe have after the purchase? Well, what we're going to do is just represent this as an algebraic expression. So if he had D dollars before going to the movie and then he spent $19.95, what he's going to have left is going to be what he started with minus what he spent on the movie. Okay, so in other words, the original amount, D, minus what he spent at the movie. So this expression, algebraic expression right here, would represent how much he has after the purchase. And if you knew how much he had going into the movie, if we knew what D represented, we could figure out how much he has after the movie simply by plugging that number in for D and subtracting $19.95. All right, let's look at example 5. So these get a little more complicated. The sum of two numbers is 3. And then 4 times the larger number plus 3 times the smaller number is 27. Find the numbers. Okay, so this one's a little bit more advanced. And this is different too, guys. The word is right here, and I probably should have put this in the notes. It's actually, well, I'm just going to write it in here. Anytime you see that word is in a verbal algebraic expression, this means you're going to get an equation because the word is represents equality. Okay, so anytime you see the word is, you're going to use an equality symbol. Okay, so let's look at this first sentence. The sum of two numbers is 3. So first of all, what we're dealing with is there are 2 unknown numbers here, and we don't know what either one of them is, and that's actually what we want to find. So what we can do is use a variable of our choice to represent those two numbers. So I'm going to use x and I'm going to use y, just because those are the most common. So we could do something like this. First number, we use x to represent it. And then for the second number, we can use y. So it says the sum of those two numbers is 3. So we know is means equals. Sum, if you look back in your chart, refers to addition. Okay? So that means this is telling us that if we add those two numbers together, it should equal 3. That's how we obtain our first equation here. It's going to be x plus y is equal to 3. And then we've got a second sentence that's going to give us another equation. It says 4 times the larger number plus 3 times the smaller number is equal to 27. Okay. So 4 times the larger number. So we could say, actually let me erase some of this. So instead of denoting these first and second number, let's denote them larger and smaller number. Okay, so x represents the larger number and y represents the smaller number. And so this says that 4 times the larger number, which is x, plus 3 times the smaller number, which is y, should equal 27. And so this is how we get our second equation. So 4 times the larger number, so 4 times x, plus 3 times the smaller number, so 3 times y, or 3y, is equal to 27. Alright, and you guys will see during lecture, this is what's known as a system of equations, guys. Now I know before, all we were doing was just translating these expressions. These were not equations, so we never had to solve anything. Down here, though, we do want to solve this system of equations for x and y. We want to figure out what those two numbers represent. Okay, and so this is where we're going to use, and we'll talk about this in lecture, what's called the elimination method. Okay, and so what I mean by that is, if you look at my two equations, I've got my x's lined up on the left, I've got my y's lined up next, and then on the other side of the equal sign, I've got my two constants lined up. So what we want to do is we want to eliminate one of these variables. Because if we can get an equation that just has one variable, we can solve it. And then we can figure out what the other variable is after that. Okay? So one thing you can try to do is think, well, for me to eliminate one of these variables, they're going to need to cancel or turn into 0, in other words. So how can we do that? Well, if you notice, so let me just arbitrarily choose to eliminate the x's. Okay? So I see that I have a positive 4x on the bottom. If I could somehow turn this x on top into a negative 4x, then if I started adding these columns, those x's would become 0, would get canceled. So the question is, well, how do I make this x on top a negative 4 so that it cancels with this positive 4? Well, we're going to multiply this top equation by negative 4. We're going to make it a negative 4. And so this is how you show it. You take that top equation and you multiply it by negative 4. And guys, as long as we multiply every term in this equation by negative 4, this equation will stay balanced. Okay? And then the bottom equation I'm going to leave the same. Just rewrite it. Okay? But to multiply the top equation by negative 4 means I need to distribute that negative 4 to all the terms in that equation. And I'm going to write my new equation over here on the right. So negative 4 times x is negative 4x. Negative 4 times y is negative 4y. Negative 4 times 3 is negative 12. Now I didn't want to change my bottom one, so I'm just going to rewrite it as is. Okay. Now what you're going to do, now that you can see that these x terms are going to cancel whenever I start adding these columns, is you're going to go ahead and draw you a horizontal line, and you're going to add those. And so negative 4x plus 4x is 0. So those get eliminated. So that's why they call this the elimination method. Now, when you go to add your y's, negative 4y plus 3y is actually a negative 1y. Bring down your equal sign. And then negative 12 plus 27 is going to give us 15. Okay. And now we've got one equation and it only has one variable in it. So we can solve it for y. So to get the y by itself, the y is getting multiplied by that negative 1. So we have to do the opposite of multiplication, which is division. So we're going to divide both sides by negative 1. So on the left-hand side, those negative 1's divide out. It's going to leave us with just positive y. And then 15 divided by negative 1 is negative 15. So here, guys, we've actually already found one of the numbers, y. And y represents the smaller number. So the smaller number is a negative number. It's negative 15. So now we need to find x. And since x is the larger of the two numbers, we expect the value for x to be bigger than negative 15. All right, so how do we do that? Well, if we know what y is, we can use either one of these two equations to find x. I usually use the top equation. Okay? And we do what's called back substitution. Okay? So that means basically you're going to take that first equation, you're going to rewrite it. You could use the second equation, it doesn't matter. You'll get the same value for x. And what we're going to do, since we now know the value of y, since it's negative 15, we can actually take negative 15 and plug it into that y. So if we do that, we'll have x plus negative 15 equals 3. And now we can solve for x. So that's how we find that other variable. Alright, so to eliminate this negative 15, guys, we're going to have to add 15 in order to turn it into a 0. So negative 15 plus 15 is 0. I meant to get red on that one. There we go. And so all we're going to have left is x. Bring down the equal sign. 3 plus 15 is 18. Okay? So now we found our second number, x. And if you go back up here, x represents the larger number. Okay? So the larger number is 18. And the smaller number, which was y, we found to be negative 15. Okay? And so this is the answer. So we're going to be seeing a lot of problems like this in the college algebra portion of 3.6. We're using the elimination method. So what we did here, we first translated these two sentences into equations. We got this system of two equations, and then we solved those two equations for x and also for y. And you could even write this as an ordered pair. 18 would go first because it represents x, and then negative 15 would go second for y. Alright, and then the last thing is I put this little table in your notes. This is just some more examples of how to translate algebraic expressions, so you guys can look over this. So like I said, we'll get some more practice with this in the college algebra portion section using this elimination method on solving a system like this, a system of linear equations.